Hey everyone, how are we doing? Let's start getting some work done. Chapter 16. Here just keeps getting longer, doesn't it? Okay. Need to go here to the 4 to 3 mark. Stat 201. Chapter. What are we doing? 16. Homework. Question 1. Let's go do it. Okay, we got last of our sodas. Trying to get rid of them, Got that problem. Sodas, get rid of them. Okay, which of the following are true? If false, explain why. A p-value of 0.01. Well, what does this mean? A p-value is the probability of our results or results from our stream happening by random chance variation given that the null is true. What that means when you break it down is, imagine someone tells you that they're the best chef in the world. Well, that'd be the null. They're the best chef. And then they make for you like Ritz crackers with like tomato sauce on them and they call it a pizza. You're going to reject the null. That's a very unlikely result. So a p-value of 0.01, it doesn't mean the null is false. I mean, it'd be evidence against the null. So it's evidence against the null, but it doesn't show it's false. It shows what we saw was unlikely. So the p-values are probabilities. That's what the P of p-value stands for. So a low p-value means the observed event was unlikely given the null is true. So it's unlikely your friend makes you this pizza disaster given that they're the best chef in the world. A p-value of 0.01 means that the null hypothesis has a 0.0. No, it's not the null's probability of occurring. It's the probability of your friend making that given they're the best chef in the world. So it's the probability of the observed results. I had a friend, Leland, who said he could run a 4-minute mile. He also said his friend could run a 3-minute mile. So when I see Leland run like a 6-minute mile, that's a very unlikely result. So the p-value goes to the probability of what you saw given the null is true. It's a conditional probability. Like if Leland is a 4-minute mile runner, I should see him do something close to 4 minutes. I observe him doing something far away from 4 minutes. That's a very unlikely result. So it's false. The p-value is not the probability that the null is true. It's the probability of the observed results given the null is true. A p-value of 0.01 is evidence against the null. That sounds true to me. The p-value is the probability of what we saw. So low p-value would be evidence for the null being false. It'd be evidence. It doesn't show the null is false. It's evidence the null is false. A p-value of 0.01 means we should definitely reject the null. Now, kind of. Got to be a little careful right here. There's this value called alpha. Alpha is just simply a bar by which we reject. So what you have to do, you reject the null. I think they probably mentioned it right here. Yeah, it's literally answer C. So it's going to be that p-value less than alpha reject the null, but alpha is usually 0.05 unless otherwise stated. So if your p-value were to be p-value equal to 0.01, typically reject the null, but it depends on the alpha level, which is right there. So typically, the p-value provides enough evidence. Rejecting the null is based on the alpha level, but usually in most circumstances, you're going to reject the null at a 0.05 level. So p-values below 0.05, reject the null. Well, that's got the first question done. Make sure to know how to do these. Make sure to know the theory. It's all theory, theory, theory. Question 2. Let's do it. Really good use and understanding of alphas and p-values here. P-levels, whatever got. Is it better to use an alpha of 0.05 or 0.01? Well, the difference here is, think about this bar. 0.05 is easier to get under this bar because you just have to get p-values lower than 0.05 to reject. 0.01 means you make less type 1 errors because your alpha is your type 1 error rate. So it's not really better. It's just what the researcher wants. If they want to be making less type 1 errors, then a lower alpha level is good, but you're also going to have more type 2 errors. Type 1 errors are related to your alpha level, and alpha, if it gets lower, beta gets higher, which is type 2 errors. So make sure to know that beta is type 2 error, and it's inversely related to alpha, because alpha is your type 1 error rate, and it's whatever you do percent of the time you reject the null. So a lower alpha lowers the probability of type 1 error, but increases type 2. Then you might want that. It should say it depends. The answer is it depends, but that's factual. If we use an alpha of 0.01, then the p-value of 0.001 is statistically significant. So how does it work? Your alpha is the bar by which you reject. This is alpha, 0.01. Your p-value is 0.001. So p-value less than alpha, if you remember from the previous question, p-value less than alpha, reject the null. So is this true? That's as true can be. P-value less than alpha, reject the null. Okay. If we use an alpha of 0.01, then we reject the null hypothesis. Wait, what? Isn't that the same thing? Oh, wait. You know what's so funny? I read the last one as you reject the null because statistically significant is the same thing as saying you reject the null. That's true. So notice the synonymous language on this. When we say something is statistically significant, my brain automatically reads reject the null without even reading it, because statistically significant means you reject the null hypothesis because the p-value is less than alpha. So 3 things that are synonymous or lead to the same conclusion: p-value less than alpha leads to rejecting the null. Rejecting the null is what statisticians call statistically significant results, or unlikely by random chance. Think unlikely low p-values. When you say something is unlikely to have occurred by random chance, what we saw was a very low probability event given the null is true. It's the observed result. A p-value of 0.01, we reject the null hypothesis for any value. Oh gosh, that's false. It'd be any value less than. So this is greater. Remember, you reject the null when the p-value is low. When the p-value is high, you just let it fly. So this is false. It should be less than. What's up? Good to see you. Always want to catch the live stream. Oh, thank you. Well, yeah. Are you here at UT? Let me throw you some points. Let me throw you a Puppet Shark. Drinking some soda today. I shouldn't, but thank you so much. Are you a UT student? Are you a around the world student? Sometimes we get people here from like, you never know where, and they're like, hey. So thank you. I really appreciate that. That means a lot to me. People catching a live stream. Minas Lament. Well, thank you so much. I really appreciate that. We're always watching the chat too. Watch me get one wrong now. Sam the Goat. Yeah, you taught my class. Oh, thank you so much. Yeah, I guess I did substitute teach earlier this semester, right? Well, thank you. I'm glad you found the channel and you're using it. Hey, we're gonna do all chapter 16 homework. So if you want to do that, keep checking this out. We're gonna put it all in this video here. If the p-value is 0.01, reject the null for any value greater. No, when the p-value is low, reject the null. It should be this. Oh, we failed to reject. Yeah, we failed to reject. Wait, what? I did that on purpose. The null hypothesis would be rejected for any value less than. That's what I said. Wait, what am I doing? Wait, it was true? What have I done? Let me read it again, like 2 times here. Oh, it's saying if the p-value. It's saying if the p-value is this. Usually you set your alpha level first. Totally did it where I set myself up for failure, right? I'll throw you some more points. I just want to make people's day having some fun right here. I thought it meant the alpha level is 0.01. If the p-value is this, then the alpha level is greater. You would reject because the p-value is lower than alpha. So that is true. That's such a weird way to do it. That's such a weird... Why would they say that? So false. Why would they say that? When the p-value is lower than alpha, reject the null. That is a weird way. Usually researchers set their alpha level and then they... Look at that. Someone's probably just did all the answers like, oh, don't do that. Okay, can we get this one? Is it A, B, C, or D? Does Brian know it? Is it A, B, C, or D? Someone else come in and say good things about me, and I'll get this one wrong. I'm having some fun today, right before break, right? What is the name of the threshold by which we reject the null? Literally, this is where my mistake happened last time. You're safe with me. With our... oh, wait, what is that? Oh, good to see you in the chat. I have no idea. Well, thank you for being here. Very nice to see you. I'm going to head out. Thank you for being here. You're welcome. Pedro's awesome too. Shouts to Pedro. And good to see you here, our other visitor. So here we are. Let's go take a look right here. What is the threshold by which we reject the null? We were just mentioning this a lot. What is the threshold by which we were rejecting the null? What is the threshold by which we reject the null? The threshold by which we reject the null. It's that bar we make, at which any point p-value less than this reject the null. I'll give the answer in a second. We'll see if anyone in the chat knows it. So this is the bar that the researcher chooses. Once again, the researcher gets to decide this. It is the alpha level, the level of significance. Effect size is the true difference between the null and the truth. Think about like how good a basketball player is. If someone believes someone makes 50% of their free throws, it'd be hard to detect if they're a 52% free throw shooter, but they're an 80% free throw shooter. That's a bigger effect. And the effect is the difference between the null and the truth. The alpha level is the point at which we reject the null, usually 0.05. Type 1 error is actually connected to alpha error, but it's when you reject the null when the null is true. Critical values are used for doing statistical tests, and they're the test statistic that we must fall beyond to reject the null. It's not commonly used with common ways of doing modern statistics. What is the probability that a test correctly rejects the false null? Very interestingly, right here, this is not an error. Let me put this in the notes. Because if you see errors right here, it is not an error. what are all these answers? You should know a definition of each one of these. Very important to know each one. Significance level, what is that? That is your alpha, which is also your type 1 error rate. It's not the answer, though. Significance level is like your 0.05 alpha. You say when we have a significance level of 0.05, p-values below 0.05 reject the null. Significance level is the point at which you reject the null, chosen by the researcher, usually 0.05. Type 2 error is if you hold up 2 right here and you make an F. Type 2 error is when the null is false and we fail to reject it. It's kind of when you think about like a false negative in a test for medical, where someone might go in and they say you're fine, but you're not. False negative, the null is false. The null being that you're healthy, that's false, but they fail to reject it. They still believe you're healthy. P-value is the probability of our results or results from our stream happening by random chance variation given that the null is true. It lets us see how probable something is given an assumption. Like, once again, we always use the example of your friend tells you that this soda will make you faster. And then you go out and you run the exact same time you've always ran. Well, if your null is that this soda will not make you faster, then your observed results of doing exactly that, not running faster, would have a high p-value because you did what you expected. But your friend might want you to reject the null. So imagine they tell you this soda will make you faster, and then you go out and run a mile and you run it in 2 minutes. Well, that'd be insane. You just broke some world records. So that'd be a very unlikely result, and that'd be the probability, we would say, is very low that you're going to run a 2-minute mile after drinking this soda. Probably won't happen. So p-values tell us the probability of something given the null is true. None of this has to do with this question, though. This question wants to know the probability of correctly rejecting the false null, which is power. Power is actually the complement of type 2 error. It's 1 minus beta. And you can think of the power of a test as the ability to find results. So think of somebody trying to, I don't know, deduce who's the best basketball player. Well, let's say the basketball player is amazing. It'd be easy to find them then. Like, if you have LeBron playing for you, you'd be like, okay, LeBron, I just watched him for a second. He's insane. But if it's me, I'm not that good. It might take a while to figure out how good Brian is. How about if you watch him versus 1 minute versus 20 minutes? What I'm alluding to is these tests get more powerful when you alter things, because it'd be more easier to detect how amazing someone is if you watch them for 20 minutes, bigger sample size, versus 1 minute. And just to draw this out, because I do want people to know these concepts, the 3 things that impact power are going to be your alpha, which is type 1 error rate, and you're going to have your effect size, which is how good of a basketball player that person is, and your sample size. If you increase these, they actually increase power. As in, if you watch the person play basketball more, if they're a lot better of a basketball player, or if you're more willing to reject that they're an average basketball player in favor of an alternative that they're a great basketball player, like you're like, man, if I see them make one shot, which would be a very high alpha, then I'll conclude they're the best basketball player in the world. Power is 1 minus beta, and beta is type 2 error, which is inversely related to these. So it's a very important infographic to know. Alpha is type 1 error. Effect size is the true difference between the null and the truth. Like, if you think someone's makes 50% of their free throws, but they actually make 100%, that'd be easy to find out. Like, you'd watch them shoot like 20 free throws and they make all of them. You'd be like, wow, you're the best free throw shooter in the world. It's easy to detect. But if they're like a 55% free throw shooter, I mean, they could shoot 20 and make 10. You'd be like, I don't know. But they're actually 55. The null is false. So effect size goes to like the true difference, like how much better are they than the null, which no one really knows that. It can only be estimated. But if there is a bigger effect, it's easier to detect. And right down here, sample size. This is if you have them shoot like 20 basketballs or 100 basketballs. It's gonna increase the power of the test, easier to reject the null. So this is power, the ability to correctly reject the false null. Next one, easy questions right here. Oh, Chris's. Okay, next question. 1843. Oh, I lost my copy paste. Okay. Question 5. What is the name for the difference between the null and the truth? Well, if you listen to that last one, we already explained it. So check out the last one if you're jumping right to this. This is what actually there is. Another example of this would be, imagine someone goes to the hospital and they have a small cough. They're like, I think I'm sick. Well, they might be. I mean, the truth might be that they're sick. We don't know the truth. It can only be estimated. But what if they're like really sick? They're like on the floor and they're like passed out. Well, that'd be a big effect. So the null being that they're healthy and the truth is that they're sick. If they have a cough, that's a small effect. But if they're on the ground passed out, that's a big effect. The effect size is the true difference between the null and the truth, whatever this difference is, like a 52% free throw shooter or someone who makes 100%, a bigger effect. Or imagine I tell you this study session right here will help your grade. If it helps it only by 1 point, that'd be hard to detect. But if it helps it by 20 points, that'd be a lot easier to detect because it's a bigger effect. So the effect size is the difference between the null and the truth. Type 1 error is a false positive when you reject the null and the null is true. Critical value is the point at which we reject, not used a lot in this class. And alpha level is the percent of time we reject the false null. We're almost done. What? It's too easy. Too easy. We gotta make these harder. Everyone should get hundreds on this. Okay, let me see. Get a bunch of texts. Family's gonna be in town. Is my phone upside down now? Nope. Just got to parking garage. Oh, I should go meet them here soon. Yay! Leaving Emily's. Yay! Come to Haslam. And let me know when you're here. We just got to the garage. Okay. Okay. Let me re-timestamp this. We should get the homework done. Okay. So this one right here. Ooh, it's type 1, type 2 error. So in a type 1, I'm going to go to the main screen. Here's the memorization of this. Are you ready? Number 1, T. Number 2, FF. So in a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. And you're only talking about the null here. Don't talk about the alternative, because you could say the null is true and you find evidence. No. In a type 1 error, the null is true and we reject it, because you shouldn't reject true things. That's an error. In a type 2 error, the null is false and we fail to reject it, because if the null is false, you should reject it. Let's do the question. Okay, a bank wants to know if the enrollment on their website is above 30%. They take a test right here where they have the null that it is 30%. They have the alternative that's greater than 30%, and they reject the null. Now, if they reject the null, that means they could have only made a type 1 error. It doesn't mean they did. Later, they find out it's actually lower. So it sounds like they did make an error. So this would be a type 1 error. It's actually lower than it. So it's weird the way they... Yeah. Let's see here. The bank made type 1 error. The actual value is not greater than 30%, but they rejected the null. The way they phrase this, the actual value is close to, but they rejected. The way they phrase it, I was worried. This is weird phrasing. The B and D are very similar. Don't like that. A student tests 100 students to determine whether other students on our campus prefer brand of A soda or brand B of soda, magical disappearing soda, and finds no evidence of a difference. That means they failed to reject the null, so they can only make a type 2 error. Later, a marketing company comes in and finds no difference. So the student found no difference, and then no difference was confirmed. So did they make an error? No. So they didn't reject the null, and then a census was done, and they didn't reject the null. No error was made, because they, like, here's what I found, and then someone else found the same thing. So that's the way it works right there. Okay. Next, we have a human resource analyst wants to know if the applicants this year score on average higher on their placement exam than the candidates did last year with 52.5. She samples this and finds out that they are 54.1. She fails to reject the null, so this wasn't enough evidence. So she can only make a type 2 error because she's failed to reject the null. At the end of the year, they found out that the applicants actually had a higher mean. This is definitely a type 2 error. So the actual value was this, which is greater than. So this is what they're doing right here. When it says this, a type 2 error is when the null is false and we fail to reject it. The actual value was greater than because the truth is that the null was false. The applicants this year were higher, but she said, I don't have enough evidence for this. She didn't reject the null. So since she failed to reject the null and the null was false because they were actually higher, she made a type 2 error. A pharmaceutical company tests whether a drug lifts the headache relief rate from 25% achieved by placebo. They failed to reject the null, so they can only make a type 2 error with a p-value that's super duper high. Further testing shows that it actually relieves the headaches of 38% of people. Okay, so this is definitely a type 2 error because it turns out it actually does relieve headaches. The null hypothesis was it used a p-value to determine its conclusion. Said no, that you can do no. Critical values need to go away. I can just read this and like p-values are how we reject the null or not reject the null. The null hypothesis was not rejected, but it was false because we should have found evidence for the alternative. Wow. Oh my gosh. I thought the last question would be tough. Really? What type of error is made when a true null hypothesis is rejected? It literally says true. So if you've memorized our mnemonic from the last question, in a type 1 error, the null is true and we reject it. That's the homework. We did it quick. We actually lectured through it. Oh man, well, my parents are going to be here in a moment. Do we have time for a tiny bit more? Where's that quiz? Where is it? Oh my gosh. Oh my gosh. Did you just close this out? We've done these. Quiz fun stuff. Ooh. Let's do this one in the video. And then I'll see if my parents are here. They're probably walking down. Need to go find them. Stat tool 1. Chapter 16. Quiz. A random poll. 900 working men. Okay. So we're going to do this one a little quick here and just have a little bit of fun. So this one uses the confidence interval to reject or not reject a value. And it all comes down to
notation brother.
So we got a sample size right here. This is p hat because it came from the sample. So p hat is equal to 0.09. That means q hat, which is 1 minus p hat, is 0.91. Find all your notation to begin with. 95% confidence interval is z equal to 1.96. If it's 90%, it's 1.645. If it's 99, it's 2.5758. Use MuBot's not even awake. What am I doing? What am I doing here? Here's the normal curve dropped in by me right there. So you can find the values on the curve for your interval. So we just need to solve out p hat, really. P hat plus or minus z star p hat q hat over n square root to get these values right in there. So I'll plug in the values so you can see it on the screen. That is going to be, I'll change pen color too, so it's a little clear that we're changing what we're doing. 0.09 plus or minus 1.96 square root 0.09 times 0.91 over 900. And very important, solve the margin of error. That's the margin of error right there. This is the standard error, and that's the critical value related to the confidence interval, and this is the estimate of the interval. So let's go ahead and get this interval going. Okay. Okay. 0.09 times 0.91 divided by 900 square root times 1.96. There's the margin of error. It's almost 2%. I wish it was. It's 1.9 when rounded. So 1.9, we're just going to take 0.019 and add it to 9%. So we're going to do that right there. So 0.109, and then this should be 0.071, because you're just taking 9% and subtracting 0.019 right there. There it is. And because, what are they saying is the claim? 5%, ooh, because 5% is not in the interval, we reject it. We have strong evidence that more than 5% of the workers are there, and we did it. Well, I'm going to go find my family. Short office hours today. We'll have some more tomorrow, and we will try to do as much of the quiz. I'm going to send out a big reminder, get this quiz done. But short office hours today because we have family in town. I don't get to see my family that often because they're over there in another state. So bye for now, everyone. Bye.